This is Group 13's F1 video for the cmpm121 final project. I'll be displaying how we fulfill each of the criteria required for F1. The important state of your game's grid must be backed into a byte array in AOS or SOA format. So if you look at our grid state, this is our logic for storing into a byte array. Each cell uses 4 bytes. We have a plant type, plant level, sun level, and water level. And this is how we store into a uint8 array. We have functions to get the raw state, and we have functions to load the raw state. So as you can see right here, I have an empty save file, right? I will go ahead and move around the player, change the state of the game. I will advance our turn. I will put zombies on the screen. As you can see, I have 127 sun and 100 water, right? Now, if I were to press S and save to, let's just do that, right? As you can see in console, it says game saved to slot, right? If I were to change the state of the game and spawn more zombies on the screen, now there's 5 zombies on the screen, right? And if I were to load the previous state, it'll take us back to when there were 3 zombies on the screen and when there was 127 sun, right? Now, if I were to press B, it will display that this slot exists in console. So that's how we can tell we have 1 slot available. And I will go ahead and save another slot. So I'll do this QQQ instead, right? So we have 197 sun. I'll move around the player, advance the turn a little bit. And if I were to load that previous save, it'll take us back to 197 sun. Now, if I wanted to display both of these save slots, I'll press B, and that's proof that we have multiple save slots. So if I wanted to delete any of these save slots, I would delete, let's say I delete that one first, right? So it says slot deleted, save slot, right? If I were to press B, it'll show that this is the only save slot available, right? And if I were to try and load that deleted save slot, it will not work. Nothing will happen, right? Now, if I wanted to delete QQQ as well, I can do that, right? And as proof, QQQ will not load anymore. And if I were to press B, the array would be completely empty. So that is proof that our save and load system works as intended. Now, if I were to display how this works in code, as you can see right here, all of our functions for save and loading logic are handled in game state. This is where we save to local storage, and I will go to the function, I will go to save slots, right? So we have save to slot. This saves the current state to local storage, right? And serialize, the function for serializing is up here. I turn it into JSON to stringify it, and so that I can actually store it in local storage. If I wanted to delete that slot, I would simply just do the same thing, except I would remove item instead of set item. And all of this logic is called inside of our scene. So we will parse for player input. For example, if I were to press S, save slot is called, and the current state will be put into that save slot. If I were to press D, that save slot would be deleted. And if I were to press L, I can load that save slot. And I would load all of the necessary information that is needed for that scene. The grid manager, the player, the plant manager, the zombie manager, everything. And if I were to press B, it simply displays available save slots in console. And the code for that is right here. Return all keys inside of the local storage. And actually, if I were to change around the states a little bit, as you can see, there's a zombie about to escape. If I were to restart and come back, autosave will put me exactly back to where I left off before. So when the autosave function is called, the current state will be serialized and it will be set to local storage. And the way that we handle autosave in the game scene is anytime the state of the game changes. For example, when we press N to skip forward in turns, for example, what I'm doing right now, right? Then the game will autosave. So the current state of the game is almost always saved anytime the state changes. Now to display our undo and redo logic, if I were to restart and not take the autosave, as you can see right here, there's 1 zombie on the screen, 2 zombies on the screen now. If I were to press Z, I can get rid of that zombie, right? And I can get rid of that zombie as well. And I can also undo all of my player movement, right? So for example, I just moved over here. I can make myself move back. And if I wanted to undo all of that, if I wanted to redo everything I just did, I would press Y. And I can actually spawn. So as you can see right here, I spawned in 4 zombies. If I wanted to make those zombies go away, I would press Z to make all the zombies go away. If I wanted to bring them back and redo everything I just undid, I would press Y. And then as you can see right here, it says in console there are no more redos available. So as you can see right here, this is our stack logic. If the stack length is greater than 1, we have this here so that there's always one state left for fallback. We pop from the stack and we push to redo, and we'll restore the state. Same logic goes for redo. If the length of the redo stack is greater than 0, then we pop from the redo stack and push to the undo stack. And we have console log statements to display whether or not the undo or redo statements were successful. And all of this can be called via player input in our default scene. So if I were to go over here, if I were to press Z, then game state undo may be called, and we have console log statements to display all the current information. Same thing goes for if I were to press Y, then redo would be displayed.